Hello. All right, let's see. Can you guys hear me? Hello. This is a collection of words intended to see if you guys can hear me. Looks like it. Congratulations, guys. I'm very happy for you. Okay, yeah, just gonna wait a bit. What are we doing? Yeah. I remember now, yeah. All right, let's see how long the delay is. I clap and see if it comes up. Okay, it's about that long. From that clap to this collection of words is the yeah. Fairly long, at least on my end. Maybe y'all got a better connection than I do. Yes. Perhaps it is fixing ownership errors. Alright, I think we're gonna start with the slice type. Alright. Right, still gonna wait for a few people to come in. If they do, let's CD into Rust for Lemmings. Just check this out. Are we going to have any actual stuff, things even? Have we already went through slices? Yes, we have. What am I talking about? Where were we last time? Oh no. We've already gone through that. And that. Enums and pattern matching. There we are. We're here. Right, we may have some issues as the thing goes on. How do I pop out chat? There we go. Definitely not the quickest. Okay, we are going to wait until some people, or I'd say about 7:40. Hoping to see Silver Sorbet in here if possible. Started a signal group. Love to get a minute if he's still here. Be a shame if he was not coming in this time. Tried looking for him on Lemmy. Kind of hard to tell if somebody is in place. I wonder if you guys can hear my heater. Hello. I don't think you guys can. That's alright. Well, I can't on my end. If you guys can, I'd love to hear it. I'm only going to wait until about 7:45-ish to start this out. Just going to start talking, honestly. Rust by example. We were looking at that. What was the thing I was looking at? There was something here. Ignore all this. Holy shit, tabs, man. Right, I'm just going to be very boring for this period of time. I have nothing to talk about. I'm quite tired. I've been talking all day. Prefer not to talk anymore, but we're gonna go over the next 2 hours. There's 2 people in chat, so some guy's just watching me, man. That's terrifying, you know? I know you're sitting there. I know what you're doing. It's nefarious, I can only imagine. Either that or it's just me twice. I don't know if Restream and Twitch separately count as a view, or if me watching even counts as a view. I really hope me watching doesn't count as a view. Like, why would it? That would be incredibly stupid. Is this a better view? Yeah, I can still hear myself in this. Like, I'm still learning what I'm doing. I don't really know. Ah, okay. I can't see how many people. Ah, yeah, I can. Alright. There's nothing else I can really do than just start, you know. Ah, it's jumped up to 4 viewers. That's very weird. I don't know what's going on there, man. Anyway, I think I'm just gonna start out. If somebody wants to catch up, I'll just re-explain what's going on. But enums and pattern matching. In this chapter, we'll look at enumerations, also referred to as enums. Enums allow you to define a type by enumerating its possible variations. First, we'll define and use an enum to show how an enum can encode meaning along with data. Next, we'll explore a particularly useful enum called option, which expresses that a value can either be something or nothing. Then we'll look at how pattern matching in the match expression makes it easy to run different code for different values of an enum. Finally, we'll cover how the if-let construct is another convenient, concise idiom available to handle enums in your code. Good stuff. I'm quite excited, honestly. The match statement is something that I've heard a lot of people state is really great with the code. I've heard a lot of people gawk about it. I don't know what the word is. They like it. It's apparently a good thing. Defining an enum. Just a moment, got a thing here. Right. Defining an enum. Where structs give you a way of grouping together related fields and data, like a rectangle with its width and height, enums give you a way of saying a value is one of a possible set of values. For example, we may want to say that rectangle is one of a set of possible shapes that also include circle and triangle. To do this, Rust allows us to encode these possibilities as an enum. Let's look at a situation we might want to express in code and see why enums are useful and more appropriate than structs in this case. Say we need to work with IP addresses. Currently, 2 major standards are used for IP addresses, version 4 and version 6. Because these are the only possibilities for an IP address that our program will come across, we can enumerate all possible variants, which is where enumeration gets its name. Any IP address can either be any IP address can be either a version 4 or version 6 address, but not both at the same time. And that property of IP addresses makes the enum data structure appropriate because an enum value can only be one of its variants. Both version 4 and 6 addresses are still fundamentally IP addresses. They should be treated as the same type when the code is handling situations that apply to any kind of address. We can express this concept in code by defining an IP address kind enumeration and listing the possible kinds of IP addresses that can exist, 4 and 5. These are the variants of the enum. Apologies for not correctly stating the words as they are written. That's going to be a continuation during this conversation. We can express this concept in code by defining an IP ADDR kind enumeration and listing the possible kinds an IP address can be, v4 and v6. There are the kinds of enum. These are the variants of the enum. Thank you. Enum IP ADDR kind, v4 and v6. IP ADDR kind is now a custom data type that we can use anywhere else in our code, or elsewhere in our code, not anywhere. We can only use it where the enum is brought in. Enum values. We can create instances of each of the two variants of IP ADDR kind, like this. And let 4 equal IP ADDR kind, : v4. Note that the variants of the enum are namespaced under its identifier, and we use a double colon to separate the two. This is useful because now both values, v4 and v5, are the same type, IP address kind. We can then, for instance, define a function that takes any IP address kind. Function route. IP underscore kind of type IP address kind. And we can call this function with either variant. Route with v4 or v6. Okay. Using enums has even more advantages. Thinking more about our IP address type Thinking more about our IP address type. At the moment, we don't have a way to store the actual IP address data. We only know what kind it is. Given that you just learned about structs in Chapter 5, you might be tempted to tackle this problem with structs, as shown in Listing 6.1. We have an enum, which simply has the two kinds. We have IP address, which has a kind, and an address, which is simply a string. We have home, which is just the struct, IP address having the kind, setting it to v4, and a string setting a value. And we have loopback, which is the same thing but in v6. Here we've defined a struct, IP_addr, that has two fields, a kind field, that is of type IP address kind, the enum we previously defined, and an address field of string type. We have two instances of the struct. The first is home. It has the value IP address kind v4, and is kind with associated address data of 127.0.0.1. The second instance is loopback. It has the other variant of IP address kind, as its kind value, v6. It has address of 1 associated with it. We've used a struct to bundle the kind and address value together. So now the variant is associated with the value. However, representing the same concept using just an enum is more concise. Rather than an enum inside of a struct, we can put data directly into each enum variant. This new definition of the IP address enum says that both v4 and v6 variants will have an associated string value. Yep, v4 string, v6 string. IP address, v4, string from here. Alright, so we call it like a function, putting in whatever we want to add as the value within the enum. That will equal home, I assume it's home dot blank, right? that how we use it, or do we have to use some form of redirection? We attach data. Alright. We attach data to each variant of the enum directly, so there is no need for an extra struct. Here it's also easier to see another detail of how enums work. The name of each enum variant that we define also becomes a function that constructs an instance of the enum. That is, IP address v4 is a function call that takes a string argument and returns an instance of IP address type. We automatically get this constructor function defined as a result of defining the enum. There's another advantage to using an enum rather than a struct. Each variant can have different types and amounts of associated data. Version 4 IP addresses will always have 4 numeric components that will have values between 0 and 255. If we wanted to store v4 addresses as 4 U8 values, but still express v6 addresses as one singular string value, we wouldn't be able to with a struct. Enums can, however, handle this case with ease. Okay. So yep, it's just a parameter, and it's always called as a function with a parameter. Looks quite nice. Let home equal IP address v4 27001. Good stuff. We've shown several different ways to define data structures to store version 4 and version 6 IP addresses. However, as it turns out, wanting to store IP addresses and encode which kind they are is so common that the standard library has a definition that we can use. Let's look how the standard library uses IP address. It has the exact enum and variants we've defined and used, but it embeds the address data inside the variants in the form of 2 different structs, which are defined differently for each variant. We have a struct. We have 2 structs. I'm sorry, what is this talking about? Okay, so what's happening here is we have v4, which is an enumerations type, which then takes in an IPv4 address, which itself is a struct. Okay, fair enough. This code illustrates that you can put any kind of data inside an enum variant, strings, numeric types, or structs. For example, you can even include another enum. Also, standard library types are often not much more complicated than what you might come up with. Note that even though the standard library contains a definition for IP address, we can still create and use our own definitions without conflict because we haven't brought the standard library's definition into our scope. We'll talk more about bringing types into scope in Chapter 7. Let's look at another example of enum, listing 6.2. This one has a wide variety of types embedded in its variants. We have enum, which is the message. We have quit, of types quit, move, takes an X and Y value, write, which takes a string, and change color, which takes an RGB value. Is this a tuple? Would this be equivalent to a tuple? I guess it would be. I mean, don't see why not. How do we access this, though? I guess that's for us to know later. This enum has 4 variants with different types. Quit has no data associated with it. Move has named fields like a struct does. Oh yeah! Sorry, never mind. Yeah, it just has named fields. I didn't notice that, yeah. Well, I did notice that, it didn't click, I guess. Alright. I wonder why they use a struct here instead of simply in each field. I guess if it gets long enough, a struct would be better practice. Is it just a struct? Can we use things that only work on structs here? Who knows? I don't know. I don't know if there's anything that only works on structs. We have write that includes a single string and change color, which is 3 I32 values. Defining an enum with variations such as the ones in listing 6.2 is similar to defining different kinds of struct definitions, except the enums don't use struct keywords. Except the enum doesn't use the struct keyword, and all the variants are grouped together under the message. The following struct could hold the same data the preceding enum variants hold. I can't read today at all. Apologies for that, guys. The 0 of you who are currently watching. I love every one of you, though. Struct quit message, unit struct. Struct move message, X and Y. Struct write message, string, as a tuple struct. Oh, okay, yeah, I guess they are tuples. These are tuples, but... Oh, yeah, I guess. That's a tuple struct. Sorry, we had learned about that before. But if we use the different structs, each of which has its own type, we couldn't as easily define a function to take any of these kinds of messages as we could with the message enum, defined in listing 6.2. Just a single type. There's one more similarity between enums and structs. Just as we're able to define methods on structs using impl or implement, we're also able to define methods on enums. Here's a method named call that we could define on our message enum. Implement message function call taking self, that the body would be here. Okay, what? So that would work over the entirety of message. That would work over the entirety of it. It wouldn't be on a specific part of it, on a specific... Is that called a type? I'm going to continue reading, but I guess that would be over its entirety. You'd have to check to see which... No, that would just be on the... Yeah, I guess you really wouldn't have to be on any of the specific types. Yeah, okay. The body of the method would use self to get the value that we call the method on. Oh yeah, so it does use self to get the value that we call this method on. In this example, we've created a variable n that has the value message write, holding a string called hello. And that is what self will be in the body of the call method when m.call runs. It'll be of type write, with hello being held within it. Let's look at another enum in the standard library that is very common and useful. Option. Excitement is incalculable. The option enum and its advantages over null value. This section explores a case study of option, which is another enum defined by the standard library. Option type encodes the very common scenario in which a value could be something or it could be nothing. For example, if you request the first item in a non-empty list, you would get a value. If you request the first item in an empty list, you would get nothing. Expressing this concept in terms of the type system means the compiler can check whether you've handled all the cases you should be handling. This functionality can prevent bugs that are extremely common in other programming languages. Programming language design is often thought of in terms of which features you include. Features you exclude are important too. Rust doesn't have the null feature many other languages have, nor are things nully, which is a weirdness to me. If you have the number 0, it won't, if 0 being the value that's brought in, will be positive, I believe. Or sorry, it won't work at all because you need to put in a boolean. There's no such thing as a nully value. I use JavaScript primarily, so that is a bit of a difference for me. Null is a value that means there is no value there. Languages with null. Variables can always be in one of the two states, null or not null. In his 2009 presentation, Null References, $1 Billion Mistake, Tony... That is a dirty last name. The inventor of null has this to say. I call it my $1 billion mistake. Oh no, even he hates it. He hates his own son. It's like my father. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, system crashes, which have probably caused $1 billion of pain and damage over the last 40 years. Oh boy, I think it's a bit over $1 billion. This is 2009, I guess. Since then, my lord, has that ever ballooned. The problem with null value is that if you try to use a null value as a not null value, you'll get an error of some kind. This null or not null property is pervasive. It's extremely easy to make this kind of error. Feel issue, man. Feel issue. However, the concept that null is trying to express is still a useful one. A null is a value that is currently invalid or absent for some reason. The problem isn't, hey, Blorpery! Blorpery? Glad to see you in here. Are you from Lemmy, or are you just popping in? Welcome either way. Very happy to see you. Never seen these little buttons. I don't think I'm supposed to have this right here. Very happy to see you then, Blorpery. If you're just coming in, we're starting to learn enumerations. Would you like me to just do a bit of a, what would the word be? Apologies, I am very scatterbrained. I just talked for the entire day, got home, talked for longer, and now I'm here. But really, you haven't missed too much. Oh, you're up to date? Glad to hear. I've lost my place, though, which is a bit of a failure on my end. Right, so one thing you'll learn quite quickly is that I am, in general, just a failure. Where are we? Here we are. Glad to have you, however. However, concept is it's a useful one. The problem isn't really with the concept, but with the particular implementation. As such, Rust does not have nulls, but it does have an enum that can encode the concept of a value being present or absent. This enum is option t, and is defined by the standard library as follows. Here we go. We have an enum of type option with none or some, taking in a type, or t, which I'm assuming is a type. The option t enum is so useful that it isn't even included in the prelude. You don't need to bring it into scope explicit. Oh, I see. The prelude is, yeah. So this is just available to us from the get-go. You don't even need to bring it into scope explicitly, it's just always in scope. Its variants are also included in the prelude. Oh, that it is included in the prelude. And there we go, a bit of a failure. You can use some and none directly without the option prefix. The option, the prefix, enum, is still just a regular enum, and some, t, and none are still variants of type option t. The t syntax is a feature of Rust we haven't talked about yet. It's a generic type parameter, and we'll cover generics in more detail in Chapter 10. For now, all you need to know is t means that some variant of option means that the sum variant of the option enum can hold one piece of data of any type, so it's TypeScript's any, and that each concrete type that gets used in place of t makes the overall option t type a different type. Okay, so we could have some. Oh, okay, yeah, I see. Here are some examples of using option values to hold number types and string types. We have some number equals sum 5, sum char, sum. Okay. So that's how matches work. I can understand that. So I've seen them a bit. It's like a match, none, and then here's the case that you work against, and then you have sum of type number, and then you have sum of type, or sum, and then you pass in. Yeah, okay, I think I understand where that's coming from. Just reading this, we have sum number 5, sum number E, absent number is just none. Option I32 of type option I32 equals none. What's happening here? Absent number equals none. I don't really understand that one. The types of sum number is option I32. The type of sum char is option char, which is a different type. None is the other possibility for option. Okay. Well, yeah, but why is it an option of type I32 versus an option of type char? None has no type on it. Why isn't an option of I32, which is also a none? Is it because... I don't really understand that, to be honest. I guess it is an option of type I32, but the type of option it is, or sorry, what is it called? I can't remember exactly what it's called. Okay, I guess I'm just going to continue reading on. I don't see why it's an option I32 of variable none. The var name is absent number, so they would have meant to return a number, but there isn't one. Okay. Alright, that makes sense. I guess this would be very unlikely to be none normally. It would be like equals and then some function call that can pass in a number, but in this case pass back none. Alright, thank you for that, Lori. Are you quite practiced in Rust? Are you just in here to watch? Do you know a lot about the language, or are you also a learner here? Because if you know a little bit of Rust, that's great. Oh, you're just a few chapters ahead? Hopefully we'll catch up with you. Would you be interested in joining a Signal group with the rest of us? There's about 3 of us currently who are learning through all of this. Just have a Signal group set up for this. Love to see you in there if you're welcome. Oh, sure. Great. After this, I'll send you a whisper on Twitch, but I don't want to do it now. I don't want there just to be a VOD with the Signal group on there. Sorry for that. Just prefer a little bit of privacy on it. But hey, I'm just going to continue on. I'll send you that later. Stay if you want. If you don't, perfectly fine too. Alright. When we have a sum value, we know that a value is present and the value is held within the sum. When we have a sum value, in some sense, it means the same thing as null. We don't have a valid value. So why is having option T any better than having null? In short, because option T and T, where T can be any type, are different types. The compiler won't let us use an option T value as if it were definitely a valid value. For example, this code won't compile because it's trying to add an I8 to an option I8. Alright, we have x of type I8 and equals 5, and we have an I8 of sum 5. We try and add it together and it fails. Cannot add option I8 to 8. No implementation for I8 plus option I8. The trait add option I8 is not implemented for I8. Of the following other types implement trait add. Okay, so this is just explaining what you can actually add to an I8. That's some pretty good error handling. That's good. Intense. In effect, this error message means that Rust doesn't understand how to add an I8 to an option I8, because they're different types. When we have a value of type of a type like I8 in Rust, the compiler will ensure that we always have a valid value. We can proceed confidently without having to check for null before using that value. Only when we have an option I8, or whatever type of value we're working with, do we have to worry about the possibility of not having a value, and the compiler will make sure we handle that case before using the value. In other words, you have to convert an option T to a T before you can perform T operations with it. Generally, this will help us catch one of the most common issues with null, assuming that something isn't null when it actually is. Okay, so just to guess, what will happen here is that we'll have some like match statement, and when it is none, we'll do something to error out to tell the user, hey, this is a failure. But when it is a number, in this case 5, we will simply take the value 5 and add it to x. Continue on with our program. Kind of like a try-catch, but forced. Eliminating the risk of incorrectly assuming a not null value helps you. Would you mind zooming into the page a little bit? Not at all. Thank you for the catch. And sorry for that. Usually I do, but I forgot to today. Is this a little bit better? I hope so. Apologies for that. Sometimes I forget people watch it on a tiny screen in the corner. It's not full screen. Alright, thank you for catching that. Right, here we are. Eliminating the risk of incorrectly assuming a not null value helps you to be more confident in your code. In order to have a value that can possibly be null, you must explicitly opt in by making the type of that value option T. Then, when you use that value, you are required to explicitly handle the case when that value is null. Everywhere that a value has a type that isn't an option T, you can safely assume that the value isn't null. Oh hey! Welcome, Silver! Very glad to see you here. You're a bit of a voyeur, I see. We got a new guy in here, Blorpery. He's awesome. I love him here. By the way, Silver, you probably heard, but we do have a Signal chat. I'm going to send you over a link to it after the stream. Love to see you there. This was a deliberate design decision for Rust to limit null's pervasiveness and increase the safety of Rust code. So how do you get the T value out of a sum variant when you have a value of type option T, so that you can use that value? The option T enum has a large number of methods that are useful in a variety of situations. You can check them out in its documentation. Becoming familiar with the methods on option T will be extremely useful in your journey with Rust. In general, in order to use an option T value, you want to have code that will handle each variant. You want some code that will run only when you have a sum T value. Only when you have a value of the type that you are looking for. And this code is allowed to use the inner T. You want some other code to run only to have a none value. And that code doesn't have a T value available. Okay, so we'll have like a none variation, we'll have a variation of the number we want, or any other differences, and then lastly, we'll likely have a default. Okay. The match expression is a control flow construct that does just this. When used with enums, it will run different code depending on which variant of the enum it has, and that code can use the data inside the matching values. Alright, here we go with the quiz. Determine whether the program will run and pass the compiler. It does, turns out. Alright, we got foo, which takes in an x of type reference to an I32. Does not take ownership. And we print x. Let main x equals null. This does not compile. Null doesn't exist. Glad that they asked that. Consider these two representations of a result type that contains a value p if a computation succeeds, or an error e if it fails. Alright, so we got results, which has an OK and an error. OK is an option of type P. Error is an option of type E, which is an error if it fails. Enum result 2 is an OK and an E. The enum result 2 is considered more idiomatic than the struct result 1 in Rust. Which statement below is not a valid reason why? This is a really strange way to write a question. I like that. I've never seen a question in any test written like this. Saying directly, this is more idiomatic, this is the better way, and let's ask why. Right, so a response. The struct is more syntactically verbose than struct than the enum. The struct contains option types, which are only intended to wrap structs. Well, that's not correct. Struct contains option types, which are only intended to wrap structs. I don't think that's it at all. I don't even know what that's saying. The option types are not only intended to wrap structs. That's incorrect. The struct could have OK and error both be none, while the enum must have at least one of them. Yeah, I think that's true. The struct uses more space and memory at runtime than the enum. I'm going to think that's the second one, honestly. Does it use more space and memory? It didn't say anything about it, so I'm guessing this is straight out telling us that it uses more space and memory. I wonder why that uses more space and memory. But I believe I'm just going to say the second one is the correct, or the incorrect one here. Let's see. Got them both correctly. I don't think it uses more space. Enums are a compile time abstraction. Okay. Well, it's stating here that it actually does use more space. Inherently, it's saying this. It was asking us for the statement below, which is not a valid reason. And apparently, a valid reason is due to the fact that structs take more space than an enum. So I guess it does actually take more space, but I'm with you. I don't see why. I really don't see why a struct would take up more space than an enum. Oh, okay. So, since an enum is simply a compile time abstraction, it changes it into something else. I don't know what exactly. I'd love to learn what. A struct is going to take more space? I'd love to learn more about that. Thank you for bringing up that it's a compile time abstraction. I'm going to look into that and see why. Alright, let's just read the context a little bit. Rust does not have null pointers. That's why this is a failure. Secondarily, it's perfectly fine to have it's perfectly fine to have structs contain option types as fields. Question asked for which is not a valid reason. But if your data structure has invariants like exactly one of two optional fields should be some, then that invariant is better ensured by use of an enum. Okay? The match control flow construct. Rust has an extremely powerful control flow construct called match, which allows you to compare a value against a series of patterns, execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. Chapter 18 will cover all the different kinds of patterns and what they do. The power of match comes from the expressiveness of the pattern, and the fact that the compiler confirms that all possible cases are handled. Okay. I wonder how it does that. Oh, because it takes in an enum, so if match takes in an enum, if match takes in an enum, then it will have to check that it has a case for every single type or a variant that the enum has. Either that, or separately, it ensures that you have a default. And if you have a default, then of course everything is going to be checked. I guess we'll learn a little bit more about that, but I think that it's due to the fact that you bring in an enum, so it'll just ensure that you have every single part of the enum checked for. But you can probably put in a default for anything else. Think of a match expression as being like a coin sorting machine. Coins slide down a track with variously sized holes along it. I pretty much got it? Hell yeah, thank you, Blorpery. And each coin falls through the first hole it encounters that it fits into. Each in the same way, values go through each pattern in a match. At the first pattern that the value fits, the value falls into the associated block to be used during execution. Speaking of coins, let's use them as an example. Think of it as a switch case. Yeah, that's what I was thinking. It's just a switch case. But a bit nicer, because it only takes a enum. I quite like this. Let's use an example in match. We can write a function that takes an unknown US coin and, in a similar way as the counting machines, determine which coin it is and returns the value in cents, as shown in listing 6-3. Alright, we have a function, value in cents, takes in a coin with a bunch of different coin types. It returns a U8. We have a match. I hate this. I hate non-explicit returns. This does not scream to me that if coin, penny is the type of coin, it'll A, return 1, and then B, return the output of coin. To me, that doesn't scream that at me. I get it because it's been bashing it into my head. But come on, you could just put an explicit return here. Let's break down the match in the value in cents function. First, we list the match keyword followed by an expression, which in this case is the value coin. It seems very similar to a conditional expression used with if. There's a big difference. With if, the condition needs to evaluate to a Boolean value. But here, it can be any type. The type of coin in this example is the coin enum, we defined on the first line. Next are the match arm. An arm has two parts, a pattern and some code. The first arm here has a pattern that is the same value. Apologies, words hard, difficulty. First arm here has a pattern that is the value coins, 2 penny. And then the equals less than or greater than operator, arrow operator, that separates the pattern and the code to run. Code, in this case, is just the value 1. Each arm is separated from the next with a comma. And I assume that you could use just scoping, just curly braces, to have more code run. It doesn't need to be one line, I'd assume. When the match expression executes, it compares the resultant value against the pattern of each arm in order. If a pattern matches the value, code associated with that pattern is executed. If that pattern doesn't match the value, execution continues to the next arm. Much as in a coin sorting machine, we can have as many arms as we need. In listing 6-3, our match has 4 arms. Code associated with each arm is an expression. The resultant value of the expression in the matching arm is the value that gets returned, the entire match expression. We don't typically use curly brackets if the match arm code is short, as it is in listing 6-3, where each arm is just a value. If you want to run multiple lines of code in a match arm, you must use curly brackets. Comma following the arm is then optional. Oh! Okay, it's optional. I'm going to use it every time. For example, the following code prints lucky penny every time the method is called say coin, 2 penny, but still returns the last value of the block, 1. So is this returned out of match? I'm sorry if I read that and didn't like catch, but I assume that you could have like let x equal match coin. Patterns that bind to value. Another useful feature of match arms is that they can bind to the parts of the values that match the pattern. That is how we can extract values out of enum variants. As an example, let's change one of our enum variants to hold data inside it. From 1999 through 2008, the United States minted quarters with different designs for each of the 50 states on one side. No other coin got state designs, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include a US state. The S in US should be capitalized. Value stored inside it, which we've done in listing 6-4. Derive debug so we can inspect the state in a minute. US state. Alabama, Alaska, and then the coin just takes in as a value the US state. Can we match on a match? Oh, but we can pull out the state as a value. Okay. Let's imagine that a friend is trying to collect all 50 state quarters. While we sort out our loose change, the coin type, we'll also call out the number of states associated with each quarter, so that if it is one our friend doesn't have, and add it to their collection. In the match expression for this code, we'll add a variable called state, the pattern that matches values to variant coin 2:quarter. When a coin 2:quarter matches, the state value variable will bind to the value that quarter state. Then we can use the state in our code for that arm like so. So we have penny, nickel, dime, and quarter, which prints state quarter from pretty printing state. Okay. We have to derive debug for that though. I guess we could put a value in for each of these enums, for each part of this enum. If we were to call value in cents coin quarter, use state Alaska, coin would be coin quarter US state Alaska. When we compare that value with each of the match arms, none of them match until we reach coin 2:quarter state. At that point, the binding for state will be the value US state Alaska. We can then use that binding in the print line expression, thus getting the inner state value out of coin enum variation for quarter. Out of the coin enum variant for quarter. Sorry about that. Matching with option. Matching with option type. In the previous section, we wanted to get the inner T value out of sum when using option T. We can also handle option T using match, as we did with the coin enum. Instead of comparing coins, we're comparing the variance of option T, but the way the match expression works remains the same. Let's say we want to write a function that takes an option I32, and if there's a value inside, adds 1 to that value. If there isn't a value inside, the function should return the none value, not attempt to perform any operations. This function is very easy to write thanks to match, and will look like listing 6.5. If function plus 1, which takes an x of option I32, outputs an option I32. Match against none says none. Sum I equals sum I plus 1. Okay, that just takes in. Okay, yeah, sure. Let 5 equal sum 5. Let 6 equal plus 1, 5. Let none equal plus 1, none. Right, so here we just have returned. We just returned a sum variable well, we just have a sum value of 5. We have plus 1, 5, which 5 being a sum, the sum variant of the option enum, holding in the number 5, it puts that into plus 1, matches against it here, hits the sum. The I is bound to the value within the sum variant, at which point we return or pass back sum, a new sum value, which is a variant of the option enum, with the value I, bound value from 5, the variable, plus 1. This is returned and bound to 6. Apologies for that, I'm just trying to drill in the nomenclature into my head. Let's examine the first execution of plus 1 in more detail. When we call plus 1, passing in 5, the variable x in the body of plus 1 will have the value sum 5. We then compare that against each match arm. Does it match none? The sum 5 value doesn't match the pattern none, so we continue to the next arm. Sum, with I being bound to the value within sum. Does sum 5 match sum I? Thus, we have the same variant. The I binds to the value contained in sum. So I takes the value 5. Code in the match arm is then executed. So we add 1 to the value of I, create a new sum value. There are total 6 inside. Now, let's consider the second call of plus 1 in listing 6-5, where x is none. We enter the match and compare against the first arm. None, it is. None is correct. That it matches, so we just return none. It matches, there's no value to add to. So the program stops and returns the none value on the right side of the arrow operator. Because the first arm matched, no other arms are compared, and thus no code is run. Combining match and enums is useful in many situations. You'll see this pattern a lot in Rust code. Match against an enum, bind a variable to the data inside, and then execute the code based on it. It's a bit tricky at first, but once you get used to it, you wish you had it in all languages. It's consistently a user favorite. I have heard so much of the match variable, match syntax? Honestly, I don't know what to call it. The match keyword. I've heard so much of this, and people who love Rust will talk and talk and talk about it. In no way did that convince me until I read this. Honestly, I quite like it, but, I don't really think I'm going to be wanting it in every language, honestly. I think that's an over-exaggeration. We'll see, though. Maybe I'll love it. Matches are exhaustive. There's one other aspect of match we need to discuss. The arms pattern must cover all possibilities. Consider this version of our plus_1 function, which has a bug and won't compile. Function +1, taking an x of option I32, returning an option of I32. Match x, sum, finding I, returning sum with I plus 1. Doesn't have the none option. What is the error? We didn't handle the none case, so this code will cause a bug. Luckily, it's a bug Rust knows how to catch. If we try to compile this code, we'll get this error. Compiling enums, error, non-exhaustive patterns, none not covered. We have, here, pattern none not covered at line 3. Note, option I32 defined here. And here is, why are we keeping that in here? I could have cleaned this up a bit, but hey, who cares? Okay, what? Is this because it's Sorry, this is just a bit confusing to read. Equals note. Note option I32 defined here in this section. Equals note. And then here's another placement, not covered. Note, the match value is of type option I32. Does anyone follow this section? I don't. This is poorly written. I don't know. Oh, I guess that's just a random note. Nope. It's defined here. Note. That's where it's not covered. Note, the match value is of type option I32. Okay, they could have put this all in one line and made it a little bit easier to read. I think they're just telling you where to refer to and find the enum that is improperly matched. Yeah, I can understand that. It's just a bit confusingly written. Sorry about that. I'm very, very tired. Right, help ensure that all possible cases are being handled by adding a match arm with a wildcard pattern or an explicit pattern as shown. We have sum, I, starting sum, I plus 1, then at the end we have none, to do. Will that generate the to do part? Whatever. But yeah, it's just telling us, hey, here is where it is not covering this type. Here is where the option I32 is defined. Here is what is not covered. And here is some suggested code. Rust knows that we didn't cover every possible case, and even knows which pattern we forgot. Matches in Rust are exhaustive. We must exhaust every last possibility in order for the code to be valid, especially in the case of option T. When Rust prevents us from forgetting to explicitly handle the none case, it protects us. When Rust prevents us from forgetting to explicitly handle the none case, it protects us from assuming that we have a value when we might have null, thus making the billion-dollar mistake discussed earlier impossible. I quite like that. Catch-all patterns and the underscore placeholder. Using enums, we can also take special actions for a few particular values, but for all of their values take one default action. Imagine we're implementing a game where you roll a 3 on the dice, your player doesn't move, but instead gets a fancy new hat. You roll a 7, player loses a fancy hat. For all other values, your players move that number. The space is on the game's board. Here's a match that implements that logic. The result of the dice roll hard-coded rather than a random value, and all other logic represented by functions without bodies, because actually implementing them is out of our scope for this example. We have left dice roll equal 9, match dice roll 3, add a fancy hat, 7, remove fancy hat, other, move player other. Right, and we have the 3 functions. For the first 2 arms, the patterns are the literal values 3 and 7. For the last arm, that covers every other possible value. Pattern is the variable we've chosen to name other. What? The code that runs for the other arm uses the variable by passing it to the move underscore player function. Alright, so I guess how do we know that it's defining a default? This code compiles, even though we haven't listed all the possible values U8 can have, because the last pattern will match all values not specifically listed. I guess just because it's one variable? This catch-all pattern meets the requirement that match must be exhaustive. Note that we have to put the catch-all arm last because the patterns are evaluated in order. Otherwise, other would always be caught and we'd always just move. If we put the catch-all arm earlier, the other arm would never run. The other arms would never run. That was poorly phrased. So Rust will warn us that we add arms after a catch-all. So it actually does just straight out warn us. That is good. Rust also has a pattern we can use when we want a catch-all but don't want to use the value in the catch-all pattern. Underscore is a special pattern that matches any value and does not bind to that value. This tells Rust that we aren't going to use the value, so Rust won't warn us about the unused variable. Yeah, this is used in a lot of other languages if you just don't want to use something. If you're creating a function that is passed into some third-party library and you don't want to use some of the things that it will have to pass into the function, you can just use an underscore and your LSP will nearly all the time just shut up about it. Same with the compiler, it won't yell at you for it. Let's change the rules of the game. Now, if you roll anything other than a 3 or a 7, you must roll again. We no longer need to use the catch-all value, so we can change our code to use underscore instead of the variable named other. Right, we have same thing up to here where we have an underscore and then we just run reroll. Good to know. This example also meets the exhaustiveness requirements because we're explicitly ignoring all other values in the last arm. We haven't forgotten anything. Finally, we'll change the rules of the game one more time so that nothing else happens on your turn if you roll anything other than a 3 or a 7. We're going to express that by using the unit value, the empty tuple type we mentioned in the tuple type section, as the code that goes with the underscore arm. Alright. That's all it's doing. It's just putting in an empty set of brackets to the empty pattern. Here we're telling Rust explicitly that we aren't going to use any other value that doesn't match a pattern in an earlier arm, and we don't want to run any code in this case. There's more about patterns and matching that we'll cover in Chapter 18. We're quite far away from that. We're in Chapter 6. And I just changed page because I'm an idiot. No, that's terrible. That is terrible UI design. I stand by that fact. I'm a web dev. I get to say this kind of stuff. Disgusting, honestly. How matches interact with ownership. An enum contains non-copyable data like a string, and you should be careful with whether a match will move or borrow its data. For example, this program using an option string will compile. We have an opt, let opt, option string equals some string hello world. Opt as read and ownership. Opt at. We've not seen that syntax. Okay, so at is of variant sum. No, what? Opt at sum.0. We've not seen this syntax. Hopefully it'll be explained later what exactly that means, but I guess that is option, which is of variant sum with the value, or I guess since that just equals hello world. I guess the value hello world has read and ownership over itself. Okay? Match opt sum of any type. Printline sum. None. I don't recognize the syntax either. I don't see it in the regular Rust book. It's not in the regular Rust book? Okay, that's extremely confusing then. And they just straight up have not... They won't explain that. I'm going to ignore it and pretend it doesn't exist. That is so weird. Right, so in match sum here, we print line sum, and then we print line. Okay, so at this point, opt loses its. Yeah, opt loses its read and ownership because it's no longer used at the end here, and it dies. Same with opt. I guess this means the value with which opt has at the end. Let's reread this. If an enum contains non-copyable. Careful, for example, this program uses an option string will compile. But if we replace the placeholder in some underscore with a variable name like some s, then the program will not compile. Okay, yeah, okay. So if we bind the value within hello world to a variable, it's like passing that variable in without borrowing it. Thus, it consumes ownership of this and then deletes it because it's no longer within scope. So opt, this point, loses read and ownership, as well as the value itself not having read or ownership. I'm assuming that S. Can we see a little bit more information? Or no, we can't. I want to know if S does gain read, write, and ownership. I mean, write is never a factor, but does it gain read and ownership? Doesn't matter, I guess. Opt, and of course here if we try and use opt, it does not have the read permission, and thus this fails to compile. Opt is a plain enum. Its type is option string, and not a reference like reference option string. Therefore, a match on opt will move non-ignored fields like S. Notice how opt loses read and own permissions sooner in the second program compared to the first. After the match expression, the data within opt has been moved, so it is illegal to read opt println. Okay. If we want to peek into opt without moving its content, the idiomatic solution is to match on a reference. Alright, so we have let opt of type option string equals some with a value hello world from a string or a string. Opt becomes reference opt, so we are matching against the reference of opt. Opt loses ownership, keeps read. Opt, and the value, I still believe that's the value, that's what it's trying to say, as read and ownership. It does not have ownership. Some S, we utilize it. At the end, when it is no longer utilized, opt regains read and ownership, or still regains ownership. And, so on some S, it regains it here. If we hit none, it regains it here. It'll regain it after all code has run, which could possibly cause it to be used. And at the end, of course, it loses everything. Right, so I wonder if there's like 3 different things in here. Like there's some S, and then there's another T, or something like that. Would it regain ownership? Where would it regain ownership? It would regain ownership in each different variant, I assume, but... Well, yeah, I guess it would just regain ownership whenever whatever variant is utilized. Sorry about that. Well, this is a compile time thing, so it wouldn't actually know. Rust will push down the reference from the outer enum, reference option string, to the inner field, reference string. Therefore, S has type reference string. Opt can be used after the match. To better understand this pushing down mechanism, see the section about binding modes in the Rust reference. This is quite small. I think I'm going to read this. Just a moment, I have to respond to a quick message. I have been gifted coffee, but I can't go get it. The sacrifices I make for you guys. Alright. I am going to actually read this. To service better ergonomics, patterns operate in different binding modes in order to make it easier to bind references to values. When a reference value is matched by a non-reference pattern, you're going to head out? Thanks for having you. Or thanks for being here. What in the world is that? I don't know what that was. It was a sound. Anyway, I'm going to message you on Twitch about the group. I very much appreciate you being here, though. Have an excellent time. I'll see you later. Oh, I see what that was. You followed me. Thank you. Anyway, here we are. To surface better ergonomics, patterns operate in different binding modes in order to make it easier to bind references to values. When reference value is matched by a non-reference pattern, it will be automatically treated as a ref or a ref-mute binding. Example, let x reference option I32 equal reference sum3. Yep, y was converted to ref y, and its type is ref I32. Alright, that's just stating that. Yeah, I guess that's explained quite well previously. Non-reference patterns include all patterns except bindings, wildcard patterns, cost patterns of reference type, and reference pattern. If a binding pattern does not explicitly have ref, ref-mute, or mute, then it uses the default binding mode to determine how the variable is bound. Default binding mode starts in move mode, which uses move semantics. When matching a pattern, the compiler starts from the outside of the pattern and works inward. Each time a reference is matched using a non-reference pattern, it will automatically dereference the value and update the default binding mode. References will set the default binding mode to ref. Mutable references will set the binding mode to ref-mute, unless the mode is already ref, in which case it remains ref. The automatically dereferenced value is still a reference. To be honest, don't understand this. Sorry about that. That wasn't exactly useful. Let's start the quiz. The terminal mother program will pass the compiler, and if so, write the expected output. We have an enum called location, point I32, range I32, I32. We have L take. Let's take L. Of type location is a location. Of type of variant range of 0 and 5. We have N, which matches here. It matches against point, any type. It matches outputting 1. I believe that, any point will simply output -1. We have a range with any input, or an input that we're not using, and N. Then we have a range which has type 0. I think this will compile. I don't see why it wouldn't. I don't see why it wouldn't. It has every single possibility, including here where it checks if there's any other possibility and outputs -2. It should compile. I don't see why not. And 0.5, it'll hit here because it'll match this. It has a range. This won't be used, though, I don't think, at all, ever. I don't see why that would ever be used. Because this matches anything, really. And it'll just output N. And will output 5. I think that's fine, unless it's going to complain about this. Unreachable code. But why would it not compile with unreachable code? That would be a poor practice. And it would print N. I believe that's correct. We have 4 questions. Consider this method implemented for the option type. Implement option. T. Function, unwrap or self, other, T. Returning, T. Other. Match self. Matching against self, the thing, or well, whatever you're trying it on. If it is a sum variable of type T, return T. This is just unwrapping. And if it's none, return whatever else you put in. Returns a reference to the object inside itself if it exists, and otherwise. I don't think it returns a reference. Returns the object inside self if it exists, and otherwise. Inserts other into self if self does not already contain a value. Nope. Returns a new option containing the object inside self exists, otherwise. I think this just unwraps it. It takes the option and then it takes whatever's inside the option and passes it out, unless there's nothing inside the option. Determine whether the program will pass the compiler. Passes, write the expected output of the program, if it were executed. Enum, either. You have left and right. Left being E assigns, right being a string. Don't see any issue here, it derives debug. Let x equal either a variant right with the string hello world in it. That won't work. Yes, it will. That's fine. That's type string. Let value equal match x. We have either left and either right. I do believe that's every variation. I don't think that there can be any other variation inside of either. You have to be one of the two. I really don't think that's an issue. Current line value. I think it will compile. I don't see any reason not. Well, it passes back s.length to value, which will, yeah, that'll be fine, I believe. I don't see any issue with this, unless it's going to say that we need a default value. We need a default output. Well, this will be a lesson either way. I'm going to say it does work and it outputs hello world. Well, no, it won't. That'll output 5, 6, 7, 8, 9, 10, 11. That'll output 11, probably. Unless I miscounted. That's 5 plus 5 plus 1 from space. Submit query. I believe that'll compile. I don't see why not. Consider these two implementations of a function to decrement an unsigned number twice. Function decr twice, v1, which takes an n of type u32. Option u32. Match n. 0? None. Okay, so if n is 0, it's none. Now 0, it outputs none. If n any other value, it'll take n minus 2. Right, so this will just take any value above 2 and subtract it by 2 if it's possible to do so within an unsigned 32. Fair enough. That is fine. I don't see any issue there. It's not asking us if it doesn't compile. I guess it does compile. Decr twice v2. We have an if statement here which does the same thing. Functions have the same behavior for some, but not all inputs, or no inputs. Alright, let's look through this. So if we have any number above 2, it'll hit. If you have 0 or 1, that'll hit. So if it equals exactly 0, equals exactly 1. Anything else, it'll just subtract it. No, but I think that this is fine. I don't see any issue here. I think these are the same thing. For all inputs of NU32, this will work. N equals exactly 0 or exactly 1. It'll output none. Same here with this match. Right, this is just a poorly put together. Within Rust code, this is simply poorly put together, but this is the same output. I believe that's true. I got 3 out of 4 correct. Right, what did I get wrong? Got the first one correct. Fantastic. Got the second one correct. It's question 3, I guess. This program does not compile. Okay, so I'm guessing it's due to the fact that this does not have every option. Let's see the correct answer. Right, this program does not compile. The match arm either right S moves the field S so that X cannot be used in the print line. There we go. I see. The issue is simply, I'm never going to get ownership. I can see that clearly. I'm glad that it's going to compile. It's going to compile like that. So yeah, the issue is that when we utilize it here, it consumes ownership and then deletes it. Well, it consumes ownership of X. Yeah. I'm glad for the compiler. Because if Rust was built the same way, but didn't have ownership, we would have a bug where we had a use after free. We would simply have a use after free issue. We would be dead and we'd try and use the pointer. That would be very bad. So I'm glad for the compiler, but I'm never going to get that. That is never going to be a one-try completion type deal for me. I wonder if there's a plugin or something to show you at every single point in time what the code you've written, what ownership it has over the code that was written. That'd be kind of cool. Like adding in the this style stuff just to the end of the well, I guess yeah, of any changes. Gotta be a plugin like that somewhere. Alright. Now we have exactly 30 minutes left. Can we get to oh yeah, we can get to the end of this in that time. At which point we'll be close to finishing, I think. Right, let's start this, and we will soon be over. Thank you again for being here, Silver Sword Bay. I am always very glad to see you. Concise control flow with if-let. The if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. Consider the program listing 6 matches on an option U8 value in the config max variable, but only wants to execute code if the value is the sum variant. Sorry, I just got a message. I believe I read that. Right, so let config max equal sum 3u8. Sorry, what is a 3u8? Is that a misspelling or is that a thing? What is a 3u8? Have you ever seen that? I don't know what a 3u8 is. Is that... That's a 0... Is that 3 of type u8? Oh, I think that is what that is. So that is 3 of type u8. Let some u8 value equal 0 u8. They're having it the same issue here in the book on 6-2. Yeah, right here. I found this explanation in the same book. All number literals except the byte literal allows a suffix like a u8. Where is that? That's in chapter 3. I guess we just missed it. Or I personally missed it, but that's good to know again. So that is 3 of type u8 instead of the default, which would be of type u32. Okay. I forgot about that entirely. That was like a month and a half ago. Good to know, though. Match config max sum max. So anything, I will print line, print out max. Anything else will do nothing. The maximum is configured to be this, and then output max. Otherwise, do nothing, if there's nothing in it or if it's something else. Match that only cares about executing code and the value is sum. The value is sum. We print out the value in the sum variant by binding the value to the variable max in the pattern. We don't want to do anything with the none value. To satisfy the match expression, we have to add underscore, arrow operator, empty tuple after processing just one variant, which is annoying boilerplate code to add. Instead, we could write this in a shorter way using if-let. The following code behaves the same as the match in listing 6-6. If it let sum max equal config underscore max, print line, max is there. Alright, so if let allows us to do just a single is match, but with one single thing that we care about. Like, hey, we only want to do something if it equals this specific value. If it does not, don't do anything with it. The if let takes a pattern and an expression separated by an equal sign. Oh. Let sum max equal config max I'm very confused. It works the same way as match, where the expression is given to the match. The pattern is its first arm. In this case, the pattern is some max. Oh, I never understood this part. I'm glad I do now. What part? This part? Or the U38? Or 3U8? Sorry, I don't know how much the delay is here. Where the expression is given to match the pattern in its first arm, in this case. Oh, let if. Or the if let. Okay. And the max binds to the value inside of sum. We can use max in the body of if let block in the same way we use max in the corresponding match arm. Code in this if let block isn't run if the value doesn't match the pattern. Using if let means less typing, less indentation, and less boilerplate code. However, we lose the exhaustive checking that match enforces. Choosing between match and if let depends on what you're trying to do in that particular situation, and whether gaining conciseness is an appropriate trade-off for losing exhaustive checking. People will always go for conciseness because they're idiots and do stuff like not put in a return statement when you're trying to return something. In other words, you can think of if-let as syntax sugar for a match that runs code when the value matches one pattern and then ignores all other values. Okay. We can include an else within the if-let. The block of code that goes with the else is the same as the block of code that will go in the underscore case in the match expression that is equivalent to the if, let, and else. Recall the coin enum definition listing 6.4, where the quarter variant also held a use state value. If we wanted to count all non-quarter coins, we see while also announcing the state of the quarters, we could also do that with a match expression like this. Let mutable count equals 0, match coin, quarter, state, print line, state quarter from blank, state. Otherwise, count plus equals 1. Or we could use an if let and else expression like this. Let mutable equals 0, coin equals 0, or count equals 0. If let coin quarter state equals coin, print line, here's where it's from, otherwise, plus equals 0. Right, okay, so the if let and else statement is just the equivalent of a match where we have two separate options. Either A, one thing if it equals a specific variant of the enumerable we are checking against, or secondarily, if it's anything else, we do something else. Can we not take in a value like we do here in else? Like, can we not do that? Who cares? Well, that would be really hard to do if there's anything that doesn't have a value on it, so I guess that wouldn't make sense. We can't. If you have a situation in which your program has logic that is too verbose to express using a match statement, remember that if let is in your Rust toolbox as well. If you have a situation in which your program has logic that is too verbose to express using a match, remember that if let is in your Rust toolbox as well. I don't understand. What is this allowing for more verbose statements? I don't understand how this allows for more verbose statements. Well, I guess I'll never know until I start coding it. Which control flow construct would be most idiomatic to use in the following function? enum location has a point and a range. Function print max range in a location. Right, so print range max. We're only utilizing a range, so an if let would make the most sense, because we only care if the range exists. If let would make the most sense here. Right, get start. Start of a range. Return the first field of range. or the only field of point. Oh, I didn't read that section for the first question. I'm going to go out and start again. Right, print the second field of range. If a walk is a range. Yeah, so that's if let anyway. We're correct on that. Returns the first field of range, or the only field of point. Based on what? Returns the first field of range, or the only field of point. I don't understand what it would base off of. Get start. The start. The first field of range, or the only field of point. Based on what? Oh, you agree? Oh yeah, you agree with the first question. I don't understand this one. Match? You think match on this one? It would make sense that it would, and just in the first one's if let, second one's match. I really just don't understand what this is asking. But match would make the most sense if it's either one or the other, and we're training logic based on it. We'd have to do a match in this situation. Anyway. Yep, we're correct on that, and we're correct on that. Let's read the context. The function only has an effect in one condition, and if let is most idiomatic. The function needs to return a value for each condition, and a match is most appropriate. I don't think you could do that with an if let else statement. I don't think you, well, no, you couldn't do that. Summary. We've now covered how to use enums and create custom types that can be one of a set of enumerated values. We've shown how the standard library's option type helps you use the type system to prevent errors. When enum values have data inside them, you can use match and if let to extract and use those values depending on how many cases you need to handle. Your Rust code programs can now express concepts in your domain using structs and enum. Creating custom types to use in your API ensures type safety. The compiler will make certain your functions only get values of the type each function expects. In order to provide a well-organized API to your users that is straightforward to use and only exposes exactly what your users will need. Let's now turn to the Rust module. Okay. We are at the end here. This is quite a small one. Ooh. What? I guess we can read this one and then end. We've got a little bit left, but I think this is about it. This is very small, so I am just going to read through this. Ownership inventory. Number 1. The ownership inventory is a series of quizzes that checks your understanding of ownership in real-world scenarios. These scenarios are inspired by common Stack Overflow questions about Rust. You can use these questions to test how well you understand ownership so far. Ownership! No! Oh no. A new technology, the in-browser IDE. Oh, hello. Oh, no, I can't eat out code. Whatever. These questions will involve Rust programs which use functions you haven't seen before. Therefore, we will use an experimental technology that supports IDE features in the browser. The IDE lets you get information about unfamiliar functions in type. For example, try doing the following action in the program before. For your mouse over replace. Oh, okay. So it's got an LSP in the browser. Hover over S2 to see its inferred type. Yep. Type string. A few important caveats about the experimental technology. Platform compatibility. The in-browser IDE does not work on touchscreens. Browser IDE has only been tested to work on Google Chrome 109 and Firefox 107. It might not work in older versions of Safari, or any versions of Safari. Memory usage. The in-browser IDE uses a WebAssembly build of the Rust Analyzer project, which can take up a fair amount of memory. While you're using a browser, so you shouldn't expect any different. Each instance of the IDE appears to take around 300 megabytes. Note, we have also received some reports of over 10 gigabytes of memory use. It's an IDE, yeah, okay, that does make sense. Scrolling. The in-browser IDE will eat your cursor if your cursor intersects with the editor while scrolling. Oh, okay. If you're having trouble scrolling the page, try moving your cursor into the rightmost scroll bar. Okay, makes sense. Load times. The IDE may take 15 seconds to initialize for a new program. It will say loading as you interact with code in the editor. The quiz. Here we go, we got 6 questions. Alright. Program 1. Will this work? Loading. Alright, honestly, I don't think I really have time for this. I'm sorry. This is 6 separate questions, and we only have about 20 more minutes. I really am sorry, Silver Sorbet, but I think I'm going to have to end this. However, I am going to send you over that signal group. Hopefully this opens up in the correct space. If not, well, that sucks. Alright. I have to go to group settings. I am sorry to quit out so quickly, though. Thank you for being understanding. You've been on Signal before, or will this be your first time for you, Silver? Oh, I can't actually whisper to you. That is a shame. Do you have any social media I can send some information to you? Sadly, we can't whisper from strangers. You have a whisper from strangers turned off. I can't do that right now. I wonder why I can't whisper to you from since you're following me, if you are. Anyway, I can't currently whisper to you. Do you have is your Lemmy Silver Sorbet? I couldn't find that originally. Ah, okay. You're on retro.pizza. I like that. That's cool as hell. I can't find you at all. Yeah, I can't find you. That is so weird. You have something turned off for this? I can see you on lemmy.ml. Am I blocked by the ML instance? That's possible. Can't find you on retro.pizza either. What in the world is going on here, man? Alright, I'll try and figure something out, but I am going to end for the day. Thank you once more, Silver Sorbet. Have an excellent night.